Good evening, pre-algebra. This is Mr. Lawrence with your flipped lesson for December 5th. I got to tell you guys, I was just a little disappointed. I could tell that some of you hadn't watched the video over the weekend. I could tell that Alexandra Morgan had totally watched the video by the things she was saying in class. Very proud of you. Some of you others had also watched the video as well. But there were some of you, and I'm not going to name any names, who know you did not watch the video. And you didn't come see me about coming to see the video. Okay? You need to be watching the videos. How can you expect to learn the material if you're not preparing? Look, we can go back to the old way where you have homework over the weekend, you don't do it, I get upset, your grade suffers, or we can keep doing this. Don't blow it by not watching the videos. Okay, so today we are talking about solving multi-step inequalities. We're solving multi-step inequalities. Easy stuff, guys. A little bit long, but not difficult. Okay? We'll look at three main types of examples. There are more types than that, but some of them you should already know how to do. All right, I'm going to put three examples up. Give me one moment. Okay, here are three sample problems. You can feel free to pause the video at any time and try to solve them on your own. I'm going to work through each one and provide a number line solution along with it, but go ahead and pause, see if you can do it, because this is actually just repetition of what we've been doing, except I need to change all of these. I need to make that a less than or equal to. I'll make this a plain old less than, and then this one I'll make a greater than or equal to. Sorry about that, easy mistake to make because they are so similar in nature. All right, with this first one, I have x's on both sides of the equation. 8x minus 7 is less than or equal to 3x plus 5. Well, I don't like this 3x here. I'm going to take it away. If I do it to one side, I have to do it to the other. Some of you forgot. I mean, you'd been using your Great Wall last week, and then all of a sudden you stopped using it. Put it back in. Don't be lazy. You know how to do this. You guys are too smart to regress just because we had a weekend. All right, so when I do that, my left-hand side ends up 5x minus 7 less than or equal to, the 3x's cancel, and I'm left with a 5. Now I just have a simple two-step inequality. I'll say, what is my goal? To get x alone. What numbers are keeping the x from being alone? The 5 and the 7. The 5 is attached by multiplication, the 7 by subtraction. Saddam tells me to undo the subtraction first, so I'll add 7 to both sides of my Great Wall. When I do that, simplify, I get 5x, which is less than or equal to 12, right? Okay, x is still not alone. I'll divide each side by 5. Why? Because it's attached by multiplication. That will undo it. Those will cancel, leaving me with the solution that x is less than or equal to 12/5. 5 goes into 12 two times. There's 2 left over, 2 and 2/5. When I go to draw my number line, I'm going to show the number 2 and 2/5. It is going to be a closed circle because there's an equal sign in the problem. I need numbers less than 2 and 2/5. Well, let me see. It seems like 2 would be less than 2 and 2/5. It seems like 0 would be less than 2 and 2/5. I will shade in that direction. Very good. All right, coming on to problem number 2. I don't like the fact that there's a 6 there, and that 6 is attached by division to that whole numerator. So to undo that, I will multiply by 6 over 1. I will multiply by 6. When I do this, these 6's cancel out. I'm simplifying diagonally. As long as it's multiplication, I can do that. All right. My left-hand side becomes 5 minus 2x. That's less than negative 6. Now I have a two-step inequality. The 5 is attached to by addition. Why? Because it's positive. So I'll subtract 5 from both sides. When I do that, I get negative 2x. Be careful. Make sure that negative comes on down in the problem. Is less than negative 11. I have a negative 2 attached to x by multiplication, so I'll divide by negative 2. Whoop, 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 whoop. I said I was going to divide by negative 2. Whoop, 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 whoop. When I multiply or divide by a negative, the symbol needs to flip. So in this case, I will get x greater than or equal to negative 11 divided by negative 2 is going to be a positive 5.5. Yeah, because 2 goes in 11 5 times. There's 1 left over. So 5 1/2. All right, let me show the 5 1/2. It's an open circle. Why? Because I did not say the word equals. And I need numbers greater than 5.5. Seems to me that 6 would be greater than 5.5. 10 would be greater than 5.5. I will shade in the direction of those numbers. Okay, number 3. Another kind of crazy one. Well, let's see here. I think the first thing I'm going to do on this one is I'm going to distribute. So I'm going to do negative 1/2 times 2x. Well, a negative 1/2 times 2 is going to be a negative 1x. Negative 1/2 times negative 8 is going to be a positive 4. I'm just asking how much is half of 8. That'll be greater than or equal to 10. Now, some of you might be wanting to flip the inequality right here because I distributed a negative 1/2. The problem is I didn't multiply both sides by the negative. If I ever have a step where I multiply both sides by the negative, that is when the inequality will flip. All right, so now Saddam will tell me to undo the addition first. When I do that, I end up with negative x greater than or equal to 6. I don't like negative x. I can slide a little 1 in there. So that means I'll divide by negative 1 on both sides. X will be whoop, 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 less than or equal to negative 6. Why did I whoop, whoop, whoop? Because I divided by a negative 6. Anytime I multiply or divide both sides of the equation by a negative, I must flip my symbol. It's just a shortcut. All right. Let me see here. I need to show negative 6 on my graph, my number line. It's going to be a closed circle because x is less than or equal to negative 6. Now, a lot of you messed this one up, but let's put some numbers on here. Negative 5, negative 4, negative 7, negative 8. And remember that as we move in this direction, the numbers get larger, which means as we move in that direction, the numbers get smaller, right? Well, if I'm at negative 6, I want numbers less than or equal to negative 6. Those numbers will be to the left of negative 6. I will shade to the left. Should never get that wrong if you are able to draw a number line. Too easy. All right, let me see how I'm doing on time here. Wow, time is fun when you're having flies. It's already been 9 minutes. Okay, that is solving multi-step inequalities. Tomorrow you'll take a little formative assessment, and that will show Mr. Underhill and myself who is getting this and who isn't, and from there we shall break you up into groups. All right, Mr. Lawrence signing off. Please remember to watch this video more than once, especially those of you struggling, or go back and watch one that you might have skipped. Mr. Lawrence signing off. Have a good night, everybody.